here we go. Stream is live. Stream is live, and we've got questions from Nate. We have got... Alright, standing by for requests. You might hear a brief echo while I sound check the stream. Sound is looking good. And we've got ourselves a smooth 1080p stream. Alright, Nate, hit me with them. Folks, we are rolling. I'll pull up Dr. Racket. And please feel free to type your questions into the stream. Oh, so in response to Nate's question concerning a named function versus Lambda, that's purely preferential. That is, or let me pull up PowerPoint. There, where was that? Oh, where is that bad boy? There he is. All right, let's see. Okay, so real quick, I'm going to explain the essential difference between using named expression versus using a lambda. Now, essentially, it is completely a matter of preference, and I'll explain why it is a matter of preference. So if you have access to the slide, you don't need access to the slides, but I'll just point out I'm on slide 17 in the scheme PowerPoint. You'll notice that we've got define. What the define keyword does is it associates, or AKA binds, any form to a name. So now when we have this idea of a form in a functional language, in this case, a form is something that gives a value. Because in functional languaging, when you're working with functional languages, all you need to worry about is the value, the return value. That's it. And you're just writing, literally, a recursive procedure that works off of your return value. So, we could do something like, let's see. Make sure my, let's see, make sure my, might need a bigger font size. Yeah, definitely gonna need bigger font size. Yeah, that looks good. There you go. Fairly straightforward. Fairly straightforward. So you define a form, you give it a value, but it can be you can compound it. It can be compounded. So define my form. Let's see if we can get. There we go. We can define instead of just a value, we can define a value with respect to a function. So we can say define, let's call it, let's use the example in PowerPoint slide 23. Absolute x if, and we need to make sure if is since it's a form itself, if negative x minus x divides x. Make sure everything got closed up, closed, closed, and closed. Cool. If I do this, same thing. Absolute value. Now, check this out. So that's one way to do it, but there's notice what we're doing is this is actually we're using define and we're defining a procedure, but this is actually a shorthand way to define a procedure. This is a shorthand way to define a procedure. And when someone uses the term unnamed procedure, you have to be very careful because it confuses folks because they're like, well, no, of course I'm naming it. I'm naming it absolute. That's the name of my procedure. But there's different. This is where the syntactic sugar of Scheme really comes into play. So, for instance, this is taking the return value of a function that we're going to declare as absolute with a parameter x. So we're actually strictly defining the function with a name that we're using to bind our form to, which is this function that returns a value. But now suppose we did something like this, where we use define once again. So we're obviously going to bind something. We're going to bind a form, and we'll just call this Lambda ABS. So this is going to be Lambda ABS. But here's the thing. So we're defining a form, and now what are we going to give the form? Well, before what we said was we're going to give the form. The form is going to be a function. But there's no difference in Scheme between the form being a function and the form receiving a function. There's no difference. So it's going to receive a function. But any unnamed function has to start with the reserved word lambda to let Scheme know, hey, we're defining a function right now, and we're defining a list of parameters. This is an unnamed function with a list of parameters that follow it. This is a function defined by its parameters. I'm gonna elaborate a little bit more in a second. Okay. I'll run this. All right, and it works. So you'll see, so essentially there's no difference. What we're saying, the only thing you need to remember is that lambda is a reserved word. That means I'm going to define us a function. I'm going to define us some function with and lambda pretty much says, hey scheme, get ready, you're going to receive a parameter list, and then you're going to receive a functional definition for a form. This is shorthand. Notice how it's one less curly brace. There is no difference in how this works, but there is a syntactic difference in how it's compiled and how it works under the hood before it gets used for processing. What this says is this is defining a form that the parameter list is tightly bound to this form. What this says, this is kind of cool, this is where our concept of binding comes in, or late binding. This idea of binding here, lambda is a form, and we don't, as of right now, as of where my cursor is right now, we have no idea what it is. But then here, we receive a form that returns a value, right? So what this allows us to do is then I can replace this, I can just straight up replace that with that. Right? That's why. What am I doing wrong here? Oh, that's why. I can straight up replace that with that. And there it goes. It returns a value. So see here, we defined lambda, and here is where we put what its return value is. Now keep in mind, you'll have to treat it differently here. You'll have to give it parameters if it takes parameters. And that's what the parentheses do. The reason we were getting errors is because the parentheses say, hey, here comes a function, which is fine. But yeah, it's cool. You can just literally copy paste your form that you want to bind to right here. Notice here you can't do that. You can't do that because you're not feeding something into your form or the variable. You're not feeding something into your form. You are literally tightly binding it as a function. So yes, essentially you would need yeah, you got to be careful. The parentheses have a higher order meaning in Scheme. They do have a higher order meaning. So does that answer your question? I can go on to an additional example. I could go on to say that, let's see, maybe we want to make our own little algorithm for something. Let's see. We can just do a quick example here. Let's say we want, let's see, Let's use a recursive procedure in Scheme. We can define factorial using Lambda that takes n, and then if n is equal to 0, then return 1. Otherwise, return n factorial the difference. N 1 close, 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 and close. We want to do factorial of 49. And there we go. That works out really well. And if we were to do the factorial of 1,000, boom, big number. Boom. Big, 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 big number. Big number. And what's cool is Scheme uses lists to represent numbers. So with a list, you can really drill down, and you can do so much. You can do so much fun mathematical processing in Scheme. It's really fast when it comes to mathematics. Really good at recursion. Recursion's inefficient in C and C++ by comparison because of the stack overhead that you have to cope with. But in Scheme, nay, not so much. It's actually quite good. You can make this smaller. There we go. Yeah, there's that. And we can go through. We can go through multi-conditional. We can go through other couple of things here. We can go through reading. Let's double check to see. Let's see. YT isn't letting me type lispy stuff. What's YT? Is that, you mean DR, Dr. Racket, or what's YT? And actually, if you want to see something in the C language, just let me know. Tell me which example you want to see in the C programming, and I'll do it real quick. Oh, how do you call a function with no name? You simply put the function definition where a return value is expected. That's all you do. Yeah, because of the chat. Yeah, I got you. Because of the chat. I get it. Yeah. Let's do a recursion example with no name. Let's see. let's just do this. This is funny. Let's just extend this. So there's that. I'm just going to do this. All right, check this out. This will be fun. I got to remind myself what it took. Hang on. Got to remind myself. Okay. Let's see if this works. Maybe this. Maybe we do something like this. Let's see. Arity mismatch. I guess I had a strategy for this. The expected number of arguments does not match the given number. It was expecting 1, given 0. Then maybe we'll just do this. Maybe we'll just do that, and we'll just say, we'll just replace this. Yeah, let's just do that. There we go, and it works. So there's your answer. So no, look what I did. So notice what I did. So keep in mind, a recursive language, is always recursive, and it's kind of weird to kind of grasp. But what I did is, so I literally double defined the language, but because it takes what it wants. So think about it. So because we already have the parameter we want, So now I'm just going to I'll just write, okay, I don't need to name my function. I'll just put it where we're expecting a return value. That's it. I can write one named function, right, and just put it where I'm expecting a return value. And then what I did is and then I just did the decrement. I just decremented n using a different fashion. I defined s to be n minus 1 instead of doing it in the passing, instead of this style, right? I passed the decrementation, but here there's nothing to pass because the scope rule here, like right here, I still have access to n, so I can't define n again. That's stupid. And if I'm using this where a return value is expected, I can't very well, I can't very well pass into this anything because I'm defining something within a function. So I can't do that. So I can just write a function where the return value is expected. And so what will happen is it'll get here, it will evaluate that, it will plug in the return value here, and it will do what we expect it to do. No, it's not. Let me show you. This is an unnamed procedure, so this is an unnamed procedure. This is unnamed procedure. We have bound this unnamed procedure to the element factorial. It's not a variable. We have bound it to the name factorial. This, though, is an unnamed procedure which contains its own unnamed procedure. This is an unnamed procedure. It contains another unnamed procedure. I can do it again. I could write it again, and it will contain another unnamed procedure. Honestly, this is as good as we can get. And let's double check. I will double check the slides, but I'm pretty sure that's as good as we can get. Let's see. Oh yeah, blah 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 blah. Scope, environment, scope example, scope example, scope example. Let's take a look. Error detection lambda, local variable, body of start engine. Oh, here we go. Unnamed procedures. All right, let's see what we got here. Ah, I see. I'm sorry, I'm making a confusion between anonymous functions and unnamed procedures. Anonymous functions. Okay, let's see here. Let's see if his example even works. Let's make sure. So let's go. Let's test his example. So unnamed procedure. So we're going to start with an open parentheses, and then we're going to do another open parentheses, which means we are actually invoking something. This is how we actually invoke it. So lambda x, which we will then invoke lambda xy. We will add x and y. And after we add x and y, we will give it 3. We'll give it 3 followed by the multiplication of 5 and x Oh, I see. And then we will give it 9. Okay, and we run this. 48. Perfect. Okay, I see what we're getting at here. Yeah, so remember how when we had factorial, and remember how the line below it I did this? I did something like this. Well, this invoked that given that. Well, look, I see now what we mean by unnamed. Take a look at this. Notice how when we define a lambda, just this is sufficient. But when we want to invoke a lambda, we could write a separate parentheses and give it the form label that is binded to it or bound to it, or we could just do it ourselves. So notice this outer parentheses actually invokes the lambda, and we're giving it the value here. We've got an inner lambda, and when that guy finishes up, we're giving it the value here, followed by the other value. So I'll give you the here's an example. So we're giving what we always work backwards. So we take 9. 9 goes into x. So here, x is 9. We have a function. What are we going to do? We're going to define a lambda, and then we're going to invoke it. We're going to invoke it with these inputs, these arguments, because the arguments appear on the right. So I type my code down just so I can see it clearly. So here, we're going to take 9, and we're going to say 9 times 5. 9 times 5, 9, 18, 27, 36 is 45. So 45 and 3 are going to go into this function here. They're going to get added, and then the output's going to recurse back, and we're going to be left with 48. 45 plus 3. And that's how you do it. So my apologies. I thought I did not know. I completely missed the fact that typing this stuff in, you can just invoke it without you. This is the thing. This is the idea behind functional programming. You don't need names. You don't need names. So you don't need names, and you can actually. And then how do we do this recursively? Gosh, without creating a label, that's a really good question. How to do it recursively? That's a really good question. Pretty sure we could just embed, maybe? Let's see if he gives us an example in the slides. Let's see. Let's see. Number conversion, binary, addition of binary, data types, data types. Mm-hmm. Okay, mapping, two's complement, mapping, encryption, deep mapping, reduce more examples, implementation of reduce, parallel computing. Okay. Okay. Programming in the large. Okay, so I'm trying to look for how to do the recursion, because, yeah, I've got unnamed procedures, and you can recurse, but it seems that you only recurse the number of times you type it in. You know what I mean? I would say just do something like what I did. I'd say just do something with like what I did with the factorial example. Well, here's the thing. Look at the problem it's asking you. Look at the problem it's asking you, and make any considerations. For instance, consider can you is there a is do you know how many times you have to recurse? Do you know the constant number of times you need to do the recursion? If it's small, then you can just type out the recursion manually. Yeah, exactly. So I think your best bet, honestly, I think, because it wants you to write a recursion. Let's see, this is homework. Let's see here. The most recent homework. Let's see. So this is homework 10 or 11. 11. No, I didn't time out yet. Cool. Homework 11. All right. I hate this view so much. I hate that view. Absolutely hate that view. There we go. Now I can actually figure out what I'm reading. Let's see. So you're doing homework 11 3.2. So create a procedure. Create a procedure that returns the last n items in the list. Create a procedure that returns the last n items in the list. So then 3.1, you use a named procedure called. Use a named procedure call. List n takes the list n to implement the task. The test case would be list n gives you the list. Should give 4 and 5. Okay. Give it a list. Give it 2. It'll return a list with the last 2. Right? Oh, so here's something interesting. So the external procedure is unnamed. The external procedure is unnamed, but could you have internal procedures that are named? It seems that you should be able. It seems that you should be able to. I mean, in the first one, your outer procedure, the one that's on the outside that you call, has a name. But this one on 3.2, you're doing the same thing, but you're just invoking it with no name. So maybe you can create a sub-procedure that does the recursion, and then maybe you create an external procedure that is an unnamed procedure, so then that procedure only needs to be called once. And then your internal procedure, the one that is named, can be invoked on the inside of it to start the recursive process. And that technically fulfills his requirements. Like, I look at this requirements document, and that fulfills the requirements. And if you lost points for that, you could take this document to the professor and your homework and say, no, I implemented this according to your specification. Does that make sense? Yeah, just yeah, I'm pretty. I think that'll be fine. I think he's just looking. I'm pretty sure he's just looking for what your external procedure is. So you'll just use, you'll write the name. You'll invoke the named procedure call. Practical reason. In a programming class, there is very few things that are practical. So, there. I mean, I guess to answer your question in a serious light, Is there a practical reason to do something like that? Well, like what I was doing before, see how if you're writing something on the fly and you're not going to store it for later use, but if you essentially are just doing mathematical computation. Well, yes, you're correct. It would be simpler to make a named proc and be done with it. You are absolutely correct. But the professor is trying to get you. Here's the reason why you're doing both versions. The reason why you're doing both versions is because this class is a language class. That's the thing. That's where folks get kind of confused. You're actually in a class about the languages and the paradigms of the languages. So that's why the exercise is having you work with the language semantics. But here's the thing, in practice, you just care about functionality. You don't really care about the semantics as long as they're clean, neat, readable, and extendable. So yeah, this, in essence, coming from a software engineering standpoint, it's absolutely dumb. But from a language perspective, if you're looking at the language of how you're implementing tasks, it's a very important concept to exercise. Yeah, but to answer your question, essentially there really isn't much of a practical sense. The only practical sense I can think of is what I did here. If you're coding an example, and you're like doing scientific computing at a university and you're just coding an example and you just want to get it done quick, well then you can just use anonymous functions and then just run it and be done with it. But let's say you're writing a scheme library and you need forms that are named. Then you might want to use named forms. So once again, it's just a coding tool. It's a tool of the language that we're trying to get you to learn. That's essentially it. Let's see if I can go into... Yeah, exactly. Yeah, if it's a function you're only going to use once and you're not going to reuse it, why name it? Why name it? You can just, and here's the cool thing about Scheme is you're spitting out scientific computing really quickly because anywhere a return value is expected, you're just plugging in your functions and just chugging along. And that's the thing is, if we look at, I'll probably link to Strustrup's talk if I. No, maybe I won't link. But if you do a Google search for Bjarne Strustrup's talk, he's the creator of C++. He talks about the history of languages and the exception of object-oriented programming. And in his talk, it's called The Essence of C++. And what he does, languages used to be built at the hardware level. And one of the first languages that was actually you didn't program for the hardware, you actually programmed for the problem, was Fortran. Fortran was the first language that actually you typed your code as a mathematical solution to the problem. You were not limited by hardware. All the hardware stuff was abstracted away, which is really cool. So this is not quite Fortran, but it's very similar in the sense that you type the mathematical definition of your solution and the code just works. For instance, if I wanted to do, that's the big deal behind it. For instance, if I wanted to do a GCD, so I'll say define GCD. Let's do our GCD Lambda n and m if it is equal, what is n equal to 0, return m, else if less than or equal to what? N is less than or equal to m, then return GCD n, the difference of m and n, and then return GCD of m and n. And invoke the GCD of 3 and 9. What did I F up? Define GCD. What did I screw up? What did I screw up? Define GCD given a lambda and an m if m I don't see what went wrong. What's going on here? Define what the heck? Did he not check his code before he typed it? What the heck? Lambda. I guarantee it's probably a parenthesis problem, but for the life of me, I have no idea what's going on. And blankets the if. I wonder if he forgot a parenthesis. I wonder if he forgot a parenthesis. Or put it in the wrong place. Let me look at the C code. If it's equal to 0, return m, else if. Oh, yep, I see what got screwed up. Yep, I see what got screwed up. So, yeah, looking at the C code, it's kind of obvious. So then return n. Oh wait, no, that should just work. If, this is an if, this is what to do if it's true, then this is what to do if it's false. If yeah, and that's that if. That's that if. This is what to do if it's true. This is what to do if it's false. What the heck? Oh man, I have no idea what's going on here. This should run fine. Time to whip out Google and Stack Overflow. Dr. Racket cannot change constant. Let's see. Oh, I bet you. I think I know. Hang on. Let's just call it define. Let's just call it Bob. I think I know. Let's just call this Bob. Yep, there it is. Alright, yeah, okay. I totally get it. Oh, good freaking grief. That was funny. That makes me laugh. No, Chen's code works fine. Chen's code works fine. It is, I totally see it. It's because in Scheme, in R5, RS, in our language, GCD is already defined in a library somewhere. Derp. GCD is already defined in a library somewhere, and so I was redefining it, and that's not allowed. That's why. Okay. That makes me laugh. All right. So so maybe we can make this my GCD. Let's make this my GCD. I want the GCD of 49 and let's do 7, 14, 21, 28, 35, 40, 49, 56. Let's try that. Yeah, there you go. There you go. Oh yeah, it works. I'm gonna save that bit. That's funny. That's funny. All right. All right. So we had some fun. All right. Well, I would like to now open the floor, see if there's any other questions. Nate, if you've got anything else for me, let's go over it. But if not, I'm going to call it a review, and I'm going to, we've only got one person watching, so I'm going to call it a review, and we're going to break for lunch. And maybe we'll do, what we'll do maybe is we'll do another one on a Saturday, just to do like an intermediate review, just in case, because I know these had low, I probably picked times that were bad for everybody. So we'll probably do something to work with that, work around that. Let's see. Let's see. So, question 5, using append. Yep, let's see. Let's take a look. So question 5, create a procedure called shuffle, gives list 1, list 2, that returns a shuffle of two lists. Shuffle the lists by alternating elements between the two lists. So the underlying algorithm is pretty straightforward. You get two lists. So you can assume they both have the same length. So you just write a recursive function. You can name it. It's fine. Write a recursive lambda that will given two lists and an index will then alternate the index into a new list. You'll then make sure you pass that new list onto its own recursive function, and then you will increment that index, and it will then take the next ones and so on and so forth. It'll continue on. Now what you could do alternatively, is every time you every time you use index, and every time you take take a letter from those first two lists, why not remove them? Why not remove the element? Huh? I mean, you could then what you could do then is you could just keep passing. What you could do is then you'll have this recursive function that takes list A, list B, and actually you might not even need the index. What you'll do is you'll just keep passing, because I know you've got this function first and rest, so you can get the first or you can get the rest, and you can get the rest of them. So why not pass down to your recursive function? Why don't you pass down a list that is the rest of these elements, and then you also have to pass the list that you're incrementally building. You have to pass the list you're incrementally building. So I can't actually give you code. I cannot give you code, but I can give you like a general idea. I can give you some pseudocode using. I can give you like some pseudocode. So you'll want, maybe you have some routine. So some routine that takes a list A, a list B, and a list T for your target. And maybe what you do is in this routine, you first check the quantity of either A or B, because you know they're going to be equal. Check the quantity, and if they're not 0, then you simply append to T. You append to T the first of A and the first of B, and then you just literally do some routine rest of A, rest of B, and T. Something like that. That seems like a pretty rough algorithm that I think you could take the rest of the way. I cannot actually give you code, but that's something I could guide you with. Ah, there you go. There you go. Good job. Good job. Don't you love those light bulb moments? Just like, boom! And you're just like, ha-ha, I win. I love it. I love it. That's why I do this. I love this. All right, so, go ahead. Anything else, Nate? I've still got some time. So anything else? I'm definitely gonna make today a Chipotle day. Definitely need Chipotle. Yeah, dude, definitely. And on top of that, if you just shoot me an email, just shoot me an email if something looks super confusing. Just send me the number it is, and then what exactly it is troubling you. And if you want to send me your code, that's fine too. And I can just help on a remote. That's fine. What tends to happen is I usually get a lot of code and a lot of requests for help Saturday and Sunday night, but usually over the weekend, I'm not on email over the weekend because it's the weekend. I mean, for people who are working, 9 to 5, weekends are weekends, and I'm usually doing my homework on the weekends. And so if everyone sends me, I mean, even if you sent me help on Saturday, I could even do that. But usually all the requests for help come on Sunday. So it's like, well, what do you want me to do? It's like Sunday already. It's already on the grace period. The grace period's almost up. Let's see. Awesome. All right, folks. Well then, since we only had one person, we really didn't have much of a competition. So Nate, you are the winner and champion of this review session, and I will call it quits here. And thank you for watching. And we will any future reviews we might do. I know we've had bad turnouts lately, so we might do an extra one. We'll see. But thanks for watching.